So this course is about data visualization, right? And today we're going to learn a little bit about data. Hopefully this gives you the vocabulary to be able to think about visualizations, the data part of data visualizations, a bit more easily and naturally without having to do too much work or have the need to ask AI, oh, ChatGPT, what's a good way to visualize this data? Today is the start of you telling ChatGPT what you want, not asking it what's good. And that's one of the hopes of this course. Okay, we're going to talk about data type, data sets, and how they can be mapped into visualizations. So let's start with a little bit of an exercise. What do you think this data set is? You can type in chat.
Should we guess what sort of information it's giving?
Yeah, just make a guess. You can't say you don't know. It is numbers.
Numbers.
I think it's height. Yep, I think this is height. But it could be other things. It could be weight in pounds. Very good. How about this? Yep.
Unit numbers?
Unit numbers could be an ID, but it could also be years in the year 2000. Yeah. Yeah, I agree. How about this? Yeah, true, false, but to a question, right? Imagine if I ask, would you attend today's lecture? And there would be the response. Yeah, some sort of Boolean, true, false. How about this? Yeah, cities, but what cities? It seems, is it more specific than just cities?
Are these like major cities, capitals of provinces?
Well, maybe. I think so. It seems like it's more specific, right? There's Vancouver 3 times, there's Toronto, but there's Tehran, and then there's Chicago. So it could also just be cities that I've lived in, or maybe houses that I've had. Or it could be hometowns of people in this course. I bet there are 3 people from Vancouver, and maybe we have someone from Chicago. How about this? This is easy. Yeah, moods, rating, emotions, that is true. A lot of times we can represent, like people understand these, right? I'm happy with the food, not happy with the food. And it looks like it's also binary. It's a sort of a Boolean, right? But it's represented in something more meaningful. Even though it could be, if I had asked you, how happy are you with this food? The answer could be, or are you happy with this food? The answer could be yes, no. But you could also just use this, and it would mean something different. We have a couple more. Any guess? There could be comments. Has the economy gotten better? How about this? Does it work with this? I don't think there's anyone that says the economy's gotten better, so it's probably not an answer to that question. How about, has the... Yeah, that could be symptoms. Answers to symptoms to a question. Very good. Last but not least, favorite artist. Yeah, that could work. Yeah, bands, musicians, very good. Yeah, it could also be concerts that a person has gone to. Even though these are names of artists, the question changes the way you think and analyze this, right? Data is usually represented not in those lists. It's more organized, and we're going to start learning about this. I think this makes it a little bit easier for you to make sense because we've now organized some data sets. So what do you think this table is? The first column is, I don't want even you to guess, it's named, right? The second column is, I think, ages. The third is probably favorite music, and the fourth is favorite food. You can make a guess. Oh, I wrote favorite game. It's not favorite game, right? This data needs cleaning because the column name is wrong. But yeah, you organize the data usually in terms of tables, right? So what we're trying to learn is that things have real world meanings, right? These symbols that we use, these numbers, these emojis, and these different things have these meanings in the real world, and that affects how we analyze data. And there's also types to this data sets. it limits the structural and mathematical interpretations that we can have from this data, right? If I ask you, what is your emotion, even though there might only be happy and sad, there's more emotions, right? But if the question is a Boolean, that limits how you will think, how you will analyze it. These data types that we talk about have names, such as, I don't know, items, lengths, attributes, positions. And then people break down data types differently. So it's not what I'm about to teach you is not something that you're going to see different names. And it's a little bit different, but associated with the data type that you've learned in programming. So when you say Boolean, you would use a different name when you're using it in the context of data visualization or databases. So in a table, in a tabular format, the rows we call objects or items, and the columns are attributes and variables. Again, it's similar to object-oriented programming that you might have learned or databases that you might have tried. In general, we have a pattern like this. A series of items, each of them have several attributes associated with them. These are values. For example, you can get for item 1 the attribute 1. So for Alireza, you can get the name, or you can get the favorite game. Even though we have these attributes, you want to start thinking about like how these attributes are put in place. Can someone find something problematic with this? The way that I'm representing this data. This is a data set about different movies. Any thoughts? Does it seem weird to you?
Do we need to have the movie ID?
Probably. There's a bigger problem. The problem is, and this is something that you'll deal with, and I was actually dealing with it today. The movie Inception, did it only have 3 roles? Probably not. It had way more actors. So does it make sense for you to do actor 1, actor 2, actor 3? It's really hard. Yeah, exactly. Why actor 1, 2, and 3? You could do something else. So even though we use tables, the way we create the tables also matters when we design data sets. So usually what you want to do is something that's longer format. We call this a long format data set. The previous one was a wide format data set. Instead of having the name of the actor just happen in different columns, you will just have one column, actor, and then you will have their names there, and then you just associate that with the name, with the movie ID or the movie name, right? And then this allows you to just be able to process that data so much more simpler. So you can now get all the actors from the movie Inception because you just need to go 2 columns as opposed to unlimited numbers of columns. So things I'm teaching you today is things that you need to think about. Again, you'll figure out later how to deal with this. Sometimes a wide format is better for some cases, right? But just think about that the way you structure the data is important. So yeah, data is not always presented in a table. We have sometimes structured data that are those spreadsheets and those tables and those relational data sets that look like this, right? You can associate different tables together. This is a very structured way of creating data sets. We have these semi-structured data sets. People who do JavaScript will probably have seen this. You have these arrays of JSON objects that have keys and have values, and you can get them. Again, this is a little bit less structured, but there is a structure to it. We're going to learn how to use this. We have semi-structured data like XML that HTML is a type of XML, and it's just so hard to read, right? This is one of my least favorite data formats to deal with, but it's structural and it's hierarchical and it's used in a lot of different places. And then we have unstructured data. Unstructured, just everything is a data set, right? This is an email, right? This text is a data, and we know it's a data because ChatGPT is built off of all of our emails and things that they have just stolen from us, right? My conspiracy theory head. And then you can have metadata about something. So you can have an email and you can have information about an email, right? You can say who it's from, where is it to, or what's the subject. So data sets sometimes are complicated, and you need to be able to deal with it. So we also, just because of the fact that data structures are problematic, are different, we need data in a long format. It is currently in a wide format. It's unstructured. We need it to be structured. We often need to do data wrangling to change one data format to another so that we can make sense of it, to make it ready to be used for a specific software. So for example, when we want to do unstructured to structured data, let's say Inception is a 2010 science fiction film directed by Christopher Nolan. The movie follows, etc., etc. It's a text. We can read it, we can understand it, but what if there's 10,000 of these? How do we analyze it? So maybe we can just count the words in this, and then now we have a table of that text. So we have now transformed the data set from unstructured to something that is structured. So we know there is the word the happening 4 times, and then the word inception happened 2 times. And you might sometimes want to do data transformation. The way we think about data often is through, especially in the context of visualization, is through variable types. So one of the more important variable types is nominal, and you can use operations such as are they equals or not. So color is a nominal data or variable type. Ordinal, there's order to it, right? You can say something is more than the other or comes after the other. Like a class, you're a freshman, you're a sophomore, you're a junior, you're a senior. That's ordinal. Seasons are ordinal. Days are ordinal. You can have quantitative data. You can do math on it. Age, height, anything that has a certain sort of number, you can do quantitative analysis on it. So like in this chart, we're having multiple of these, right? So the revenue for these movie genres is a numerical data set, is a numerical variable. The genre is a categorical or nominal data set. And then the year is temporal. So what type of data is this? Any guesses? It is ordinal. And it's of a specific kind. It's temporal. What type of data is this? Yes, quantitative, numerical. Very good. What type of data is this? Correct. But also ordinal? Because hot, warm, and cold have a sense of order to them, I think. What type of data is correct? Okay. Now that we learned a little bit about the type of data that we are thinking about, we can also think about these data in different ways as well, right? Data can be formatted as a one-dimensional, 2D, you can have 3D data sets. It's a number of variables. You can have n-dimensional, you can have temporal formats, you can have trees, you can have networks. All of these different types of organizing the data kind of determines what you will do with when you want to create the visualizations. So a lot of the things that we learn in this comes from study of signs, because we do a lot of communications from signs, right? Images are often perceived as sets of signs, at least Jacques Bertin understands it that way. And then the sender, the author, encodes that information in signs. So when I do language, when I do visualizations, or I am encoding information, and the receiver then decodes it from those signs, right? So some of the ways that we encode this information for visualization is pretty simple. We first decide where we want to put elements of visualization in space, in a two-dimensional space, right? And then we decide what type of graphical elements we want to use for those. We want to use circles, lines, rectangles, hearts. And then we can also alter the graphical properties of those marks, right? So we can change the size, we can change the shape, we can change the color, we can change the orientation, we can change the opacity, and can maybe change the texture, and we might be able to change other things. Okay? So these are the things that you have in your arsenal to manipulate and create visualizations. What we do is taking those data types and map them to these different graphical properties. So you can say you have a map of a country and you want to show which country has more population. You might use circles as your marks, and then you might create different sizes associated with different populations, right? And this process is what we call encoding. And we basically taking that information that is of a data type and then encoding it into a graphical mark with certain properties in part of a space. And what we're going to learn later is that these encoding types that you're going to be able to use have different qualities for different tasks. For example, for me to be able to accurately understand a number, and we saw that in the one-piece case last session, some of these encodings in position or in length might be more help people to read that information more accurately. Another way to think about these data sets is how many variables are we trying to visualize. So we learned about encoding. Again, these are vocabulary that I'm helping you to understand, and we're going to be repeating this. So if you feel a little lost, it's all good. You're going to be practicing all of these. You can have univariate data variables, bivariate things, trivariate things, and hypervariate things. And visualizations change based on how many variables of that data set you want to produce. So again, going back to our data set of movies, Inception, Dark Knight, Avatar. Are these any of these movies you guys like? My favorite is Lion King. But anyways, I keep distracting myself when I say things I like. Inception? Have you seen Paprika? Dark Knight. Dark Knight? Cool. Dark Knight is one of my favorites as well. Anyways, we need to have that session and talk about fun things. So, let's think about this movie data set. A univariate representation is when you, for different item, you want to represent only one of those variables, one of those columns. Okay? So for example, for different movies, you can just visualize the revenue they made, right? And a bar plot is a univariate representation of that variable for these items. You can have univariate representations for things that are in aggregate. So you can take all those movies, calculate which one came in spring and summer, and then show the total box of it. That is still a univariate representation. When you want to show two things together to understand relationships between these, you can use maybe a scatter plot. So in a scatter plot, each of these circles is one of our items. Let's say each circle here is a person, and then we can map how bald they are and how old they are together as a scatter plot. And this gives us a bivariate representation. So in our case of movies, you can show budget versus box office revenue. And you might say, oh, it seems like the more budget you have, the more box office revenue you have. You can create associations with them. Okay, so any ideas for trivariate representations? How would you create a 3 variables? How would you visualize 3 variables together? Maybe through a 3D scatter plot. You can have x for one variable, y for another variable, and z. In Canada, we say z or z? Z, I think. Z for the third variable. Okay? But we could also do something more creative. You can use just a scatter plot for age and baldness. Exactly. You can then use color. Very good, right? You can use color or size to represent the third variable. That is exactly a very good point, right? So here we have a 2D scatter plot. X and Y are representing 2 variables, and then we get to a trivariate. And you can add color to this, and you can make it hyper-variate, right? So again, we can have budget, revenue, and then marketing budget in another thing, right? So we see, oh, it might also be the marketing budget that is influencing how we do things. Hopefully, when you start using Tableau, you're going to start using this language a lot, because Tableau is based on this language. And for whoever use color, we can totally do that. We can represent the graphical quality, the encoding of our march. You can just come and change the color instead of size. And then we can ask this question, for these two, which one makes more sense? Which one is easier to distinguish? And then someone has asked this question, and you might have a sense. You can do weird things. This is still a trivariate representation. So this is connected scatter plot of budget versus revenue. The line is representing which film comes earlier. So you're trying to tell a story by just connecting dots together. You know what the 2019 movie was that did poorly from Martin Scorsese's films? You guys like Martin Scorsese's movies? Here we go. So we start, this is a trivariate representation. We start with Taxi Driver, Raging Bull. It starts getting more revenue, right? And then budget reduces, and then we have just a lot of revenue and with budget, and then we have a massive budget and not a lot of revenue. But maybe this is only box office revenue, and then Irishman wasn't available in cinemas that much. So we might tell a story about something but miss other data sets. We've seen scatter plots before. Some maps are basically scatter plots, but the x and y variables have meanings. They have semantic meanings, right? They represent a place on Earth. And we can do the same connected scatter plot on a real map. So now this is a visualization that I created to show locations of protests during the Hong Kong protests that happened a while ago. So you can start by finding the number 1. They started around central side of Hong Kong, but then after time passed, they moved around, and then they went to different places to disrupt different universities and have their voices heard. You can also just represent variables separately and just place them together. This is another way of doing trivariate representations, right? So you can have 3 bar plots together, and people can read it. This is actually a good idea sometimes, not to try to do like a lot of scatter plots, because that's harder to understand. You can just say, okay, for Avatar, everything was high, you can compare different things. You can compare movies together this way. So this is an interesting way of doing trivariate representations. And then hypervariate representations are tough. And it's often interesting to be able to figure out and visualize that, right? But one good solution always is to just do this, right? Group things together and then maybe do a bivariate representation for each of them and then also put them close to each other. Hopefully you'll start learning some of these strategies when you try to visualize. The way you group visualizations together really matters. It determines how you compare things. Here you can compare easily films within summer, spring, and winter and see that maybe winter films tend to have more revenue or budget. But this is a really fun hypervariate representation. This is a visualization that my friend Emily found. Can you guess? This is one I really like. Can you guess how many variables are in this visualization? More than 2, I think. So we are showing whether dogs are dumb or clever. We are also representing their size. We're also representing just the breed, I believe. Yeah. So then you're also representing through position 2 other things, right? Popularity and just a score. Okay? So you can see that, smart dogs are really popular. Or is it smart? I don't know. It's hard to read, but it's fun. And sometimes you just want to use tables. Sometimes because tables are data visualizations, you're organizing things in a nice way. It really helps with looking up values, compare individual values. You're very precise with reading them, but it takes a long time to find it. And then the way you organize table helps. You can do something with like borders, or you can make it nicer to move around and read. So again, sometimes if you want to use tables, you can. Lines are interesting because it helps you reveal relationship among these different values for these different years. And the shape helps you read these information. Okay. And now we're getting to some of the more boring parts of data visualization. Boring because this is something that you will all end up having to do. I consider myself with a PhD in data cleaning, data janitorial, I call it, because a lot of my time was spent on just being able to process data. Usually, data sets come in with something like this, very just ugly and just hard to parse through. And then you will have to start processing that data. You will have to start cleaning it and then finding out information, right? A lot of the time that we spend is spent through cleaning and organizing data. You may need to manipulate data prior to analysis. You need to reformat, you need to clean, assess the quality, and integrate it. So sometimes you want to write custom scripts, just manually go in and clean the data. There are some data wrangler tools. And honestly, this is something that AI is pretty good at. You could ask AI to clean the data for you. But beware, sometimes it will do something and it will do it wrong, and then you will not notice it and you will have problems. But it's gotten good. I will give you a good example of something that AI might help you do. For example, if you have written different names, by mistake, it can help you organize it. So some of the potential data quality problems, you might have missing data. There's no measurements, there's redactions. You might have to convert a type, so from position, latitude and longitude to a zip code, or vice versa, because you need to be able to visualize it. Sometimes there are different values for the same thing. You need to resolve that. You need to integrate the data. When you combine different data sources together, there's problems. So here's a data set that has missing data. So for Avatar, the budget is not present. For Titanic, the budget is not present, and so on and so forth. Do you notice problems in this data set?
We put some dictation problems in.
There are some dictation problems. What else? But do you think there's a negative budget for some of the films? Misspellings, outliers. These are errors that you might have in your data set. You might have to deal with it. Entity resolution, what we were talking about is that you can't really count films by Chris Nolan in this data set because there is Nolan, Christopher, and Christopher Nolan. This is something that you have to figure out and fix. You might have to convert these data sets to each other. And then after you do all of that, then you get to some of the things that we will start to learn about. You can clean up your charts. Just a highlight of some of the things that we will learn. It just feels so much better. So this exercise is something that you will do with Mehdi in the evening. But think about it. And then, yeah, for today, we're done. That's what we needed to learn about data today. Any questions? Hopefully this was a short enough session. Yeah, less than an hour. A lot of our lectures will be like this, and we will spend a lot of our time practicing and learning with different examples. Yes, we will have lab every Monday. And by lab, there's some lectures, but it's more technical. Yes, I will post the recording that we just did to Canvas and to YouTube, and I'll send it on Discord as well. That's the whole goal of doing this recording, so that students can check it out later, other people can check it out, but like we'll have the recordings, we do read the readings, and interact with us. We're going to start having assignments. These assignments will basically be things that you will incorporate the knowledge you learn from the lectures and things. Mehdi and I will teach you more technical things. We will try to combine all of that together. Today, Mehdi will teach you some Tableau. He's a great teacher. I've had him before as a TA, and he just does such a good job. And then we're going to go from there. We're going to have some fun. We're going to make things together, and we're going to slowly learn how to code and how to create visualizations and how to make good, fun, interesting visualization. Hopefully you'll enjoy it. I'm going to send a poll to find a time that a lot of you can show up. This way, the more people interact with me, it's way more fun for me. Otherwise, I would have to just ask questions from Cadzilla and talk to them, and because I designed my lectures in an interactive way. But thank you for coming, and yeah, I'll see you this evening.
Take care, guys.